to product and quotient rules. Sorry, I don't like to say that. That's why I didn't want you to really memorize this. I wanted you to see it and why this happens. But this time I'm going to say, please memorize. To be memorized. To be committed to memory. So there are rules in the book that are slightly different than what I'm showing you. If you don't like mine, use theirs. If you find something else that works and it's the same, use it. So let's say we have a product of two functions and we want to differentiate. I like to keep it in the correct order without twisting anything. But your book is twisting them, but it's the same thing. So I accept anything that works. So I keep them in the same order, F, G, F, G. So it's F prime times G and plus F times G prime. Your book either presents G F prime or G prime F. I don't know why. It's the same thing. Use it if you like it. Okay? They twist this one. Whatever. It doesn't matter. What I would like you to remember in general is function 1 times function 2 prime. It doesn't matter. FG, whatever it is. I keep it in the form of 1, 2, 1, 2. First function prime times the second function plus the first times the second prime. And I always have it 1, 2, 1, 2, but I have to remember that here the first one is differentiated and here the second one is differentiated. So that's our product rule. I didn't write it, sorry. Product rule. Obviously. But I should have it there. Good. So let's look at a couple of examples. Here is, f of x equals x to the third plus 2x multiplied by e to the x. So this is a product of two functions. This is my function 1 and this is my function 2. So then when I differentiate, I have to differentiate the first function, which is 3x squared plus 2. I have to multiply it by the second function. I have to put plus. I copy the first function. And I multiply it by the second one prime. But this is the nicest function on the planet. It's e to the x. Can I simplify? Yes, and I should. Or at least try. These two have e to the x in common. I can put e to the x in front. Or following, it doesn't matter. So then I have 3x squared plus 2 plus x cubed plus 2x. Yes, I will write it one more time to arrange everything in descending order. So e to the x, and in descending order is x cubed. Next is plus 3x squared. Next plus 2x, and next plus 2. And this is it. Here is another quick example. F of x equals x to 5 halves times e to the x. Another typical example in which I have function 1 and function 2. I have no choice but to use the product rule. So then f prime of x is the first function prime. I bring 5 halves in front. and subtract 1 from the power. So from 5/2, when I subtract 1, the least common denominator is 2. I need to multiply the top by 2, so I have 5 minus 2, which is 3. So 3/2 multiplied by the second function, then I write plus, I copy the first function, and of course I multiply by the second one prime, but it happens to be e to the x. I wouldn't take this any further, even if you factor out e to the x. You could also factor out x to 3/2. We could. I always factor out the smallest degree. So e to the x, first x to 3/2, and then e to the x, and let's see what is left. This is out, so only 5/2 is left, and plus, from 5/2, I subtract 3/2, and I get 2/2, which is 1. Let's look at the quotient rule. The quotient rule is very similar, but it's a quotient. F divided by G. The numerator is the same with the product, but minus in between the two. The denominator is just G squared. So I only have to copy from the product. F prime G, F G prime. So this is the quotient rule. So see the similarities, please. Notice the similarities between, this is the product, same, but it's minus. If you twist this, if you swap these, it's completely wrong. If you swap these, it's fine, right here. If that's what you want to do, that's no problem. But if you swap these products, then it will be wrong. Careful. Okay, so let's take a look at f of x equals 1 minus x e to the x over x plus e to the x. This is not a trivial situation, and you'll see in a moment why. Let me also write, if you want to use this formula, first function prime, first function over the second function, everything prime. This is 1 prime times 2, of course, minus 1 times 2 prime over the denominator, which is 2 squared. Same thing.
When you say if you switch it, it'll be wrong, what exactly are you talking about? Which one's switching? Just if like G prime was
So if you write here fg prime minus f prime g, that would be wrong.
Okay.
But if you write gf prime, that's correct. If you write g prime f, that's correct. But if you put this one first and make it positive, and this one second and make it negative, that would be incorrect. I'm saying it because I saw it. Is this okay so far?
Yeah.
Good. So now f prime, x plus e to the x squared. Now you have to be very careful, because the numerator also has a product. Function 1, function 2. So when I differentiate this, I differentiate 1 and I get 0. Then I see minus, leave it alone and leave it outside. I differentiate the first function to get 1 times the second function, which is e to the x, and then plus. I copy the first function and differentiate the second one. Nice. This is only the top prime times the denominator. So I have this and I have this right now. And now I copy minus, this minus. Now I copy the top function, which is 1 minus x e to the x. So this is done. Finally, I have to differentiate the denominator, which is not a big deal because I have 1 plus e to the x. And close the parenthesis. See if you have any questions on this problem. Any questions on this problem? Any questions? Is it done? No. We have to simplify it. Because I see a negative sign here, and I see a negative sign here, and because I always want to simplify and factor, I put the minus in front. Now everything is positive, except when I get here, that's a different story. But I put a negative and negative. I factored out from these two terms, I factored out negative 1. X times e to the x. X times e to the x. E to the x times e to the x. Copy the base, add the exponents. One more time, e to the x times e to the x, copy the base, add the exponents. Plus x e to 2x. So this is now this product. Remember, this is plus now. 1 distributed to 1, plus 1. 1 distributed to negative x e to the x. E to the x distributed to 1. E to the x distributed to negative x e to the x is negative x e to 2x. X plus e to the x squared. I'm hoping that we can get rid of something, anything, really anything. Let's see. X e to the x and negative x e to the x. At least something. X e to 2x negative and x, no. X e to 2x and negative and positive. X, yes. At least something. Okay, now 1, 2, 3, 4 terms, they do not have anything in common, so my simplified form stays as we see it. So x squared e to the x plus e to 2x plus e to x and plus 1. Do not ever distribute or expand the denominators. I don't want you to be tempted to simplify anything. You can't simplify anything. And this is it on that problem. Any questions? Any questions on this? Okay, moving on. I would like to look at another example. Something like we are given a function h of x, which is g of x, another function, over 1 plus another function, f. 3 different functions, f, g, and h. And they're asking us to find h prime of 2. That's our question. And they're giving us some information. I'm going to copy the information, f of 2. They say it's negative 3. g of 2, they say is 4. F prime of 2, they say is negative 2. And g prime of 2, they say is 7. So they want us to determine this. So here's a question for you. I'm making a point. I'm telling you, find t of 3. What will you say? What will you say? I'm asking you to find t of 3. What would be your question? You don't know anything. I'm asking.
What number is t substituted in for?
Exactly. The question is, give me the function. Give me t of x. If you have t of x, you can plug in 3. The point I'm making here is you cannot plug in 2 till you find what?
G of x and f of x?
Till you find h prime of x. You cannot plug in 3 or 2 in anything before you determine the function. So before we find h prime of x, there is no discussion. You say, I have no idea. I don't know where to plug it in. What do I do? Give me the function first. So then, I need to apply the quotient rule. The denominator is nice. I don't have to ever differentiate it in a quotient. But numerator has 2 steps. And it has to have minus in between. So the top function is g prime. The top function prime is g prime. In parentheses 1 plus f of x minus. I copy the top, but I differentiate the denominator. But when I differentiate 1, I get 0. So this is just simply times f prime of x. Now you can say, I see. Now I have the function. Now you can plug in 2. You can say, but you don't really have the function. Oh, I do. It's given indirectly. I don't care. I wasn't given g of x or f of x, but now I have an expression for h prime. And now I can find h prime of 2. Is g prime of 2 is 1 plus f of 2 minus g of 2 times f prime of 2 over 1 plus f of 2, everything squared. And now I know what to do next. I just need to plug it in. And I will have h prime of 2. Can anyone explain in words what will h prime of 2 represent? So I can write the definition of this. So we know what it is. And then we'll calculate it. Calculate it is important, but not as important as understanding what it means. We wrote this before the end of chapter 2. It's the rate of change, instantaneous. To be exact. Rate of change of h of x when what? When?
X is 2.
Thank you very much. When x is 2. It can be the instantaneous velocity if h is a distance function. It can be the slope of the tangent line at 2. All these 3. It's also the derivative at 2. So now I'm going to plug in the numbers and get a final answer. So this will be, I continue here, g prime of 2, g prime of 2, 7, 1 plus f of 2, negative 3, minus g of 2, 4, times f prime of 2, negative 2, over 1 plus, again, f of 2 is negative 3, and I square that. So this is negative 2 times 4 is negative 14. This is positive 8. This is 1 minus 3, which is negative 2 squared, which is 4. So the numerator is negative 6. The denominator is 4. And I got negative 3/2. So the slope of the tangent line to the graph of function h at 2